As we then drop over to the right here, we have amplitude scale, peak and RMS. Basically, this is something that shortly will disappear. Okay? The reason we had the option here of peak and RMS is 6 years ago or so, we had a software version called 1.9, and before that 8 and 7, 1.8 and 1.7. But all three of those software packages were measured with RMS, which is root mean squared. Okay? The problem with RMS is it tends to have low amplitudes and the higher frequencies. Okay? As computers had gotten faster, laptops more powerful, desktops more powerful, you could go to a peak-to-peak measurement because it did require more processing power. Okay? Now that we're to the point that just about, I don't know if there's any equipment out there anymore that's RMS. In the EEG world, there's other things that are measured RMS, but we're talking EEG right now. Peak-to-peak is industry standard. Okay, the reason we left RMS there is if you happen to come way back from 1.9 and you were used to looking at somebody's theta and it was high at 6 or 8, it was hard for people to sometimes make the adjustment, and that same person would come in and when it was peak to peak it would be 15. Same person, same measurement, same amplitude, different scale. It's like measuring from A to B in inches and measuring from A to B in centimeters. It's the same distance, you're going to get a different number. Okay? Does that make sense? I'm hoping in the next couple updates we'll just remove this, since it doesn't really make any more sense to even have an RMS option. RMS tends to be 2.8 times lower than peak to peak in amplitude. Okay, which isn't a problem in lower frequencies, but it is a problem if you're doing any beta, high beta, gamma type training. Numbers are so small it's hard to do anything with them. Okay? Save EEG to disk. Default it to off. This has nothing to do with I want to review my session, I want to see a line graph showing me amplitude changes over time. Nothing to do with that. What this has to do with is I want to watch the session again as if it was my first time, and it was like I set up a video camera over the person's shoulder and I want to watch the raw waves. Okay? I can change different displays on the screen, I can change the music, I can look at different things. It's simply recording the raw EEG. Alright? So,
if you ever want to save them as a file that you can actually send to somebody else for a contact.
exactly. Why would you do this? Or I'm going to answer both. Why would you do this? Why wouldn't you just always have it on? Okay? Why would you do this? One, you're sending a unit home. You want to be able to look at that raw wave to make sure they had a clean signal to start with while they trained. So when you get the information back from the client, you can review a session or two and say, oh, they had a pretty clean signal, everything looks good, blah, blah, blah. Or, I'm having a problem, I can't seem to get the results I want. You put it on, you do a session, you send it to a colleague, they can review it and watch it as if they were standing there. Okay? Now, why wouldn't you have it on all the time? It's a space hog. Okay? With the newer computers, is it as much of an issue with these 500 gigabyte hard drives? Not really. However, 4 channel Z-score training, 30 minutes long, about 16 megabytes. Okay. Not a ton of space on a 500 gigabyte hard drive. However, if I'm emailing that file, problematic. What if I'm on session 10? Now I got a 160 megabyte file I'm trying to email. Did I really need to save the raw? Maybe not. Maybe they just needed to review it. Go ahead.
And how do you verify what's happened over a training session and saving data?
Well, it's saving the data. It's not saving the raw. You can still look at all the graphs. You can look at all the numbers. You can do all that. You just can't see the wave running across the screen. Well, if you have your artifact rejection threshold, you know it didn't have artifact higher than 90 microvolts or whatever you set it at. Like I said, you can even have it on all the time. There's pros and cons. Some people do leave it on all the time. Some people don't worry about emailing. They're sending a thumb drive back and forth. They're sending some other type of media that they don't care about size. Again, they have 500 gigabyte hard drive, going to take forever to fill it up. It's on all the time for every file. They don't care. They want to be able to review the file. They want to check for artifacts. They want to check for this, check for that. We give you the option.
And then there is an option to easily remove it from the hard drive?
Oh yeah, you can delete the files. The key where it gets tricky is if you're emailing files around. That's the biggest stumbling block.
Would there be a way to save just a small sampling of the EEG without it?
Yes, it's also able to be turned on and off from the training screen, so you can record a 2-minute segment.
Okay. And it doesn't,
Not have to do 30 minutes.
that's within the session?
Yeah, like at any time as the session's going, you can click on Save EEG to Disk, wait 2 minutes, click it again, it only saves that 2 minutes.
Oh, okay.
Okay? All right,
How much did you say the 14 and 30 minutes?
around 16 megabytes, if I'm not 16, if I'm not mistaken. Okay? Artifact threshold, and this is the artifact rejection threshold. I like this number at 90, okay, to start. The reason being is when you start the session, you're going to see the threshold on the screen and be able to adjust it tighter or looser very quickly. If not, if it's at 240, it's way off the screen, you don't see it. Sometimes you're hitting the R key going, where is this threshold at? Not realizing you had your caps lock on and you're now up to 500 instead of down to 90. You're going the wrong way. Thus, if it's at 90, you see the 2 pink lines, you can adjust them in and out real quick and easy. Boom, done. Okay? Does that make sense? It'll make more sense when we're at the training screen and we're watching it. And you'll see it's real quick and easy to adjust it then versus guessing where it's at. Okay? Notch filters.
Why is it defaulted to 240?
Just a number that was picked out of the air, basically.
Okay.
Bill, if we're getting somebody that has some tick or something like that, it's going to, the lower the number, the more it's going to get rid of it, right? Is that what you're
Well, think of it this way. Here's how I do it, is if you have a raw EEG and there's kind of like that settling point where it's going within a range pretty consistently, but if an event happens like a cough or a sneeze or some kind of tick or a jaw clench or something, you see this additional like spiking or whatever. So I tighten it around what's normal so that anything out of that, quote, normal range is removed from the data set. There's no feedback given. It does not record it in the set. It doesn't give you credit for it, basically. So a kid can't sit there, trick the system, and grit his teeth and get 1,000,000 points. Okay? Basically. Is that making sense? Did I answer the question right there?
I'm not sure.
It'll be easy to show you from the training screen because you kind of see a range that the EEG is normally in. So we tighten these 2 bands around the outside, not touching it, but within, let's say, 5 microvolts high or low from where the peaks are, peaks and valleys. So if something happens like a sneeze, that thing spikes out of the normal range, it's removed. You don't want it so tight that every other second it's hitting the artifact rejection threshold, but you don't want it so loose that they can move around, shake around, and it thinks that's real data. Okay, does that make sense?